Hey everyone, welcome back to Chemistry 1, where the topic that we will be discussing as far as practicing problems are going to cover problems about finding empirical formulas, and these problems are going to be a little bit more challenging. The first one that we're going to talk about is a sample hydrocarbon has 79.9% carbon. What is the empirical formula? This one is not direct, so that's why I considered it intermediate, because one thing that you need to be able to complete this problem is the knowledge of what a hydrocarbon is. A hydrocarbon means that the compound is only made up of hydrogen and carbon. Now, when it says here that it's 79.9%, on its face, you're just like, well, it doesn't equal 100%. So how do I figure this out? You'd only be able to figure it out if you knew that because it's a hydrocarbon, it can only have a C and an H. So in the formula, so C is 79.9%. So then hydrogen is how much? Well, it's going to be 100 minus 79.9%, which is 20.01%. Now we have what we need to start the process, because now we can substitute this percentage units to grams. So it's really 20.1 grams of hydrogen and 79.9 grams of carbon. 79.9 grams. We're going to do our dimensional analysis of carbon. Is equal to 6.652 mole of carbon, and then 20.1 grams of hydrogen using dimensional analysis. Canceled out. Mole of hydrogen, and that calculation is 19.940. Which one of the two is smallest? It's going to be this one. So now I'm going to do 6.652 divided by 6.652. And then for hydrogen, 19.940.652. That's one. And then for hydrogen, it's 2.997, which we can approximate to 3. Therefore, it is CH3. So just some minor things that you have to have knowledge of from your chemistry course in order to solve this particular problem. So for example, for you to do this in your class, two things. You would have to know from your coursework material for that exam what a hydrocarbon was. And your teacher considered it fair game to put it there without explicitly explaining that it's a compound made of hydrogen and carbon. Or you would have she'll put it on there, or you would have had to know, because you've had so much experience in taking your chemistry course, that it's ingrained in your brain now that a hydrocarbon is made of hydrogen and carbon. All right, and then the last problem I have is stating that you have a sample oxide of nitrogen that has 30.45% of nitrogen. What is the empirical formula? Kind of a similar situation. Here, it's important for you to know what an oxide of nitrogen is. In particular, that means that compound is made up of only oxygen, which is the oxide part, and nitrogen. So if we have 30.45% of nitrogen, how much do we have of oxygen? That's the question. That's going to be 100 minus 30.45. And that's going to give me 69.45%. But I can change it now from percentage to grams. So this is really 30.45 grams of nitrogen and 69.45 grams of oxygen. Now we can go from gram to mole and solve the problem like we know how to do it. So let's start with nitrogen. 30.45 grams of nitrogen. We're going to change that to moles of nitrogen. For the periodic table, the bottom is going to be 14.007 grams. Cancel, cancel. Answer from the math is 2.174. And then 69.45, that's got to be 55. I apologize. Let me change that. Because over here, it's 55. Oxygen. 1 mole of oxygen, grams of oxygen, 16. The math comes out to 4.347. The smallest item that we have is this one. So we're going to divide both moles by that amount. .999, which is approximate to 2. Therefore, the formula is why is it not working? NO2. Alrighty, guys, that's it for this video. I'll see y'all in the next. Hope this was helpful.